Okay.
All right. It says a spherical rubber ball has a radius of 10 centimeters. Calculate the volume and surface area of the ball and interpret your answers. So if we go to our list, we have a sphere. The volume is 4/3 pi r cubed. The surface area is 4 pi r squared.
Wait, is that going to be on our text?
Yup.
What?
Have I made you memorize any formulas yet this year?
No, so why don't we memorize it now?
I said that's my point.
No rubber.
That's the point. Do you think you're going to have to memorize
I
it?
can't sit here and pay attention.
I know.
Wait, yeah, you can. You got this.
I
Okay.
already got a 0 on this freaking assignment using ChatGPT, so.
Oh God.
Let's interpret the meanings or interpret our answers then. What is the volume representing?
How much space is?
Yeah.
Great. How much stuff is contained inside the sphere? What is the surface area representing?
The outside.
Like how much outside fully? Like I don't even know how to say it.
I would say the amount of material
It's on the outside.
you need to make the ball,
Yeah.
right?
How long? There's no material on the ball.
Because it says a spherical rubber ball. I assume it's got air in the middle.
Okay,
Right.
so now.
Everybody feel okay there?
No, can you leave it up there for a second?
I'm just going to scroll a little bit.
Or I just copied it.
Where did we get 10 from?
It tells us the radius is 10.
Don't listen to me.
I did though. It's too late. You should have told me that before I answered. All right. The next question here says we got a grain storage container that's in the shape of a cylinder with a radius of 3.5 and a height of 7. But stuck on top of that, the roof of that container is it's not a dog, it's a hemisphere. So it's not, there's no roofing.
No roofing.
Yeah, none of those either.
No one's getting roofing.
We're asked to find the volume for the container. Do you guys get what we're describing here?
Sure.
With a cylinder with a hemisphere stuck on top of it?
Yeah, I think so.
I agree.
You guys have been driving down, in the country and seen like a silo on a farm.
Yeah.
That's kind of what we're talking about. Let me drop that
What
in.
did you do?
It's like the principle,
So like a dome.
oh, boom, there you go.
Something like
What
that.
do you call it?
Oh, it looks like those things, those water towers.
It's a.
Like a grain silo. I know none of you guys are from the country.
No, we all see it. James on those two of those on Fatal Fields before, man.
Great. There we go.
Oh, look at the picture.
Wait, then.
Fortnite?
So if we want the volume in total, that's just going to be the volume of the hemisphere plus the volume of the cylinder, right?
Okay.
So I go and I look up my formulas. So the volume for the hemisphere is 2/3 pi r cubed. So the radius there is 3.5, it tells us.
What does that say plus CSL?
CYL, short for cylinder. And then we have the volume for the cylinder is pi r squared times the height. Everybody feel okay there? Part B then asks for the surface area of the grain container. So here we have to be a little bit careful, right? So the surface area is just going to be like the sides plus the roof, right? Well, the bottom's not a surface because it's sitting on the ground, right?
Yeah.
Now, if it was like a container you could hold in your hand, then yes, the bottom would count. But if it's
In the ground.
but if it's sitting on the ground, it's like how much,
That's good to know.
like if you wanted to paint the thing, how much paint would you need to do it?
I thought they were doing that.
So if we look at our formulas for this, for surface area, So if I look at the cylinder, the surface area formula is this, right? 2 pi r squared plus 2 pi r h, right? So the 2 pi r squared part is for the top and bottom of the cylinder. Now in our situation, we don't need either one of those because the bottom is sitting on the ground and then we have a hemisphere sitting on the top, right? So we don't have to paint the top or bottom of the cylinder at all. Everybody agree? So we're just going to take this part and then we have the hemisphere part. So that's 2 pi r squared. So if we plug that stuff in, and then it's just grind your numbers out, right? Everybody's good with me just plugging the numbers in the formula, not grinding it out, right? Yeah. It's typing it into your calculator. Like, who gives up? Yep. I think it's one of the show the setup, and we'll just, everybody can type stuff in the calculator proficiently at this point. Yeah. Everybody happy with what we've done so far on this one? No big deal?
Are we like reviewing? I thought we were done.
So we had to finish section 4.4. So this is the last of 4.4 that we're doing right now. And they'll talk about the test format. You guys, if there's stuff on there you want to do questions about, we can do some stuff. And if not, just let you guys work on whatever you need to be working on next. Okay. It says we have a chocolate bar in the shape of a right triangular prism. We want to calculate the volume of the bar and the surface area of the bar. Yeah, like a Toblerone is a weird triangular shape. So if I go to my formulas, the volume of the triangular prism is the area of the base times the length. So the bases in our case of a prism is the part like the parallel sides. So the bases are the triangles, right? So we'll do area of the base times the length. And the base in our case is 1/2 base times height because it's a triangle. Everybody feel good there? So if I look at the triangle here, we're told that that side is 4, that side is 2. We need that third side though, right? Because if it's a right angle, this guy's the height, and that's like the base, right? Everybody feel okay there? So how would we find that side H? You could do the Pythagorean theorem. The other way you could do that is observe that this is a 30, 60, 90 triangle. So the side lengths occur in those ratios. So you know it's going to just be 2√3.
Question.
Yeah, Nora, what's up?
So for the Pythagorean theorem, the a squared plus b squared equals c squared. Is that like where the c squared is the hypotenuse, right?
Correct.
See, can we go with that higher level education?
Everybody feel okay with how we did that?
Yes.
And then the surface area, I'm going to just think about this from the picture. So how many surfaces do I have? Well, I have 2 triangles, right? And those 2 triangles are the same. And then I have this rectangle. And I have this rectangle. And those are different. And then I have like that rectangle. They're all three are different rectangles. Everybody can see that?
Yeah.
Okay. So we're just going to add up those different parts. Exactly right. So we know the area for the triangle because we did that just a moment ago. So the first rectangle, we'll say, is this bottom one. So that's just going to be 2 times 5, right? The next rectangle, we'll say, is this one in front. That's 4 times 5. And then the last rectangle is going to be this one in the back. So that's going to be 5 by 2 root 3, right? And there we go. Sure, what's up?
So like this is pretty easy, just adding up things. But like you could definitely easily your mistake of 5 for a 4 or something. Let's say like you're like plugging in one number wrong, that changes the entire thing. Would the entire answer be wrong? So let's say 2-point question, you get 0 points, or like if you actually do the math right, would you get like half a point off?
So if you showed me this, and you just had like, and I saw that, oh, that number's just plugged in wrong, it's like a half a point to me, right? If you just have the number and it's wrong and I don't have any way of knowing why it's wrong,
And then that's
I can't give you any partial credit for it, you know what I mean?
yeah.
But if you have like this that tells me, okay, I see what you're trying to do, breaking it up into basically 4 shapes or 5 shapes or whatever you want to think about it as, that's great. Okay, you have the stuff filled in, the numbers filled in to like what you would have typed into your calculator to get it, great. Oops, I can see, where the mistake is. If I can see what the mistake is, and it seems like something silly, it's just a half a point.
Yeah.
If it's like a major conceptual mistake, maybe it's 1 point or something. But does that feel fair? Okay. It just like, again, it's helpful to be clear as to like what the expectation is and right, what I would be looking for as the grader or whatnot. All right. Last example. The Cheops is what I've decided that I'm going to pronounce that as. Pyramid in Giza, Egypt, as opposed to Giza, Columbus, Ohio, or Giza, Ohio. All the pyramids there. Shown in figure 4.36 is a right square pyramid with base length and width of 230 meters and a height of 147. 3 of the bases are labeled B, C, and D, while the apex is labeled A. The projection of the apex on the base is labeled O. So here's your picture.
Ooh.
Okay.
Are you giving, like, if you're like really descriptive, are you going to give us the picture, or are we supposed to be into
So I would say that like for a picture this complicated, you'd have a drawing with it,
But if it's like
as opposed to like, I even think this thing is simple enough to where like you should be able to envision that and draw your own picture for it. But certainly something like this, where just like a sphere, like you don't even need a picture. Okay. It says to start, find the volume of the pyramid. So I'll go to my formulas up here at the top. The volume for a pyramid is 1/3 area of the base times the height. The base in this case is a square. So we're all done there. Everybody feel good? Okay. Yep, and just reading the right formula and being able to put the numbers in the right spot. Pretty simple. Find the length of the diagonal BD. So BD is this line here. To do that, I'm going to just use that triangle as like a calculation triangle. Now, since I know that the pyramid is a square pyramid, I know both those sides are the same length. So to find CD, I'm sorry, that's supposed to be, those are in the wrong spot. You could do the Pythagorean theorem, or you could recognize that this is a 45, 45, 90 triangle, so this side is like 230 root 2. Go ahead, Tori. Sure.
No, sit down.
Again, you could Pythagorean theorem that if you wanted to. I just used the special right triangles. Then it says find the length of AB. So to find AB, I'm going to use this as my calculation triangle. Everybody okay there? And this is often the trickiest part, is just like being able to find the little triangle inside of the problem that you want to use. So I know AO is 147. We're told that in the problem, the height of the pyramid. OB, I should recognize this as 1/2 of BD, right? So hopefully you remember from your geometry class, I know someone's going to laugh when I say that the diagonals of a square are perpendicular bisectors of one another. So if this is a square pyramid and we're projecting the apex down, that should land at the intersection of those diagonals.
Yes.
And it looks like it should be too, right?
Yeah.
You don't have to prove it. I'm just kind of reminding you. So that would be like 115 square root 2 then. So I just took my answer for BD and divided it by 2. So my answer for AB then is just going to be the square root of that thing, just using the Pythagorean theorem. So when I do that, I get about 219. So far, so good? Sure. Then for part D, it asks, find the size of angle BAC and angle OBA. So BAC is a new triangle, so let's draw that one. So this is our triangle. What do you notice about this triangle? It's not a right triangle, right? But it is isosceles, absolutely.
Oh, what was that?
So if I do that and I draw in a height,
Wait, how do we know this is? Oh, because it's. I'm just
that's okay, because it's a square pyramid. Yep. Everybody good with that? So I know an isosceles triangle is going to, if I draw that altitude in there from the apex angle, it's going to be an angle bisector and a perpendicular bisector. So that allows me then to say that like this section is 115 and that section is 115. So I can do like, I can say angle BA, well, let's call this X, is going to be like sine inverse of opposite over hypotenuse. And then the angle BAC is going to be 2 times angle BAX. Everybody happy there? Alternatively, you could have used the law of cosines to do this, I suppose, also, but that feels like a lot of overkill. Since it was an isosceles triangle, you definitely don't need to use that heavy duty of a tool. Right triangle trig will be plenty to take care of it, but you could have used the law of cosines if you wanted to, because it is like a like a side situation, right? The other thing that they asked us for was angle OBA.
Is A the top? Yeah.
A is the top. So we did this. We found that this was 115 root 2. That was 147. And we're looking for this angle here. So again, we can just find that using right triangle trig. So opposite over adjacent. And that should come out to be like 42 degrees. I guess this one, I should write this down. This was 63 degrees-ish. Yeah, I just rounded to the nearest degree for whatever reason, because that's what the textbook did. I'm just looking at their answers, so I don't have to type in my calculator. Olivia, you look concerned. You're okay? And then the last one is to find the area of ABC, and then the lateral area of the Cheops pyramid. So we're looking for 63 now. We know that. We just found it. 219, 219, and then 230. What I would do is I would use my 1/2 AB sine C. And then I'm done. Because I have like an angle side angle situation going on right here. Or a side angle side situation. So I can use that area formula. If you had wanted to, you could have taken this previous drawing and calculated that height there. Wouldn't have been hard. It would just been like a, like a SOHCAHTOA problem.
So you use the negative sine cosine tangent
When you're trying to find an angle. Yeah, yep. The inverse is output angles. The regulars output a ratio of side lengths. That finishes up 4.4.
yeah.
So our test description. What's up? No, usually 3 times is a lot. Last semester, I think I had the same class 3 times. Yeah, it was fun. What was best was the test days, where I just sat there and like this all day.
And then you start off your day with the safety and you end off your day with the acceptance.
I did to get a break in the middle though.
Yeah, you do.
All right. So the test, this one feels like it was kind of on the long side. It was a lot of pages when I printed it off.
Well, the quiz was long.
No.
I thought the quiz was long.
But part of that is like you have diagrams and stuff, like you have triangles and shapes and stuff. Like I think it was like 10 or 11 pages, which feels like, yeah. But if you can only get like 2 questions on a page,
okay, that's not bad.
it's like, well, one of them is probably the formula sheet, or 2 of them might be formulas.
Okay, that's fair.
But yeah, I mean, it felt kind of long, but again, none of this is complicated, right? All these problems are like,
Yeah, it's very like.
just like use the formula, output the answer, write it down.
Yeah.
So you should be able to find the distance between 2 points, find the midpoint, the equation of the perpendicular bisector. This one felt like on the quiz we had some issues here. So most of you guys found the right slope. A lot of us didn't have it go through the midpoint. The perpendicular bisector needs to go pass through the midpoint. I passed back your quiz. You can look. I saw it happen. That was the most common mistake on that problem.
I'm like very sure. Oh, I probably did it right.
Yeah.
No, I mean.
Should be able to plot points on an XY axis. Should be able to find the intersection of two lines algebraically. This, again, was something that seemed like it gave us some problems. What are the techniques to solve for the intersection of two lines?
This is
Substitution or elimination, guys, right? If they're in slope-intercept form, just do substitution. If they're both equal to y, you set the x-halves equal to each other, solve for x. Plug that answer into either of the two startings, and you're done. If they're like standard form, then maybe you do an elimination instead. If you have one of each, I'd probably do substitution because you already have the y equals. I just plug the x, that x stuff in for the y and the other one and just be done with it. You know what I mean? I'm sure that you guys can do this effectively. You weren't ready to do it then. You should be able to solve for sides and angles in right triangles. Solve right triangle story problems, possibly including angles of elevation depression. Again, the most common mistake, one of the ones on the most common mistakes on the quiz was like putting your angle of depression in the wrong spot. Remember, like,
oh, you mean like it was supposed to be like a side angle and you like angle side?
more like you have like the person up here and they're looking down at something down here, and it says there's like a 40-degree angle depression. You guys, a lot of people put it here. It's the wrong spot. It's always from the line of sight. Yeah, a lot of people made that mistake.
Because then that goes to select the angle of elevation would be the one on the bottom right.
So this one would be an angle of elevation then. Yep.
Oh yeah. Yes, I did it correct. Hey, oh. Thanks, I guess.
Okay. So again, just wanting to touch on that. That was a common mistake. Should be able to solve for sides and angles in non-right triangles. How do you do that? Law of sines and law of cosines. So you just use the appropriate one, right? When do we use law of sines?
When you're trying to find the
Angle, side, angle, 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 side, 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 angle.
angle side side.
I always say side, side, angle for that reason.
That's my bad. I should know.
And then when do we use law of cosines?
When there's no things.
Side, 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 and side, angle, side.
So that'd be
Nope.
It's the law of cosine.
Yeah, the formulas will be on there, but the when to use them will not.
Can you technically do law cosines for everything? Nope.
No, you don't have enough information.
For what? What could we do?
So if you had angle, side, if you have two angles, can't do law of cosines with that. And side, side, angle, you have the wrong angle. And then you should be able to solve surface area and volume problems like we did for this, like these examples here, like the Cheops pyramid is a good one, where we ask you to solve for the volume or the surface area and then like do some other stuff with it too, like find some other measurements in it. But that's basically the gist of it. I don't think this stuff is really hard at all. It's just about being careful and making sure that you're reading and paying attention to what you're doing. But it should be all pretty doable.
Thank you.
No problem, Maya. Have a good day.
You too. I'll see you on Thursday. Right? Wednesday. You have a
Wednesday.
great day, everyone. I'll see you on Wednesday for my amazing task.
You're amazing.
You're all amazing.
Stay strong.
Everybody feel okay with the test format stuff? Is there any? Yeah, it's really like the same it's the same as the quiz, but we've added like these two other types of problems, which are, again, I don't think are very hard because we've done them all before, or are just like fairly simple problems. The trickiest piece of the surface area and volume thing is making sure that you're, like using the right formula, finding the right triangle inside of your three-dimensional figure to solve for a measurement or an angle measure or something. But it should be fairly straightforward. Do you guys have stuff that you want to go over as a review, or? I think this should be fairly simple, you know, like. When I wrote out the list, I'm like, none of this stuff should be anything we're bad at.
This is like pretty. I'm having more trouble with. I have to make it my chapter 11 test. So I'm gonna be studying more for that.
Yeah, that
So you spent
that's.
last week? Well, actually, I was gone. Oh, were you? Yeah.
Last week. Where you at?
Okay.
I think that's a much harder test than this one was.
You should like give me a hug.
It wasn't bad though. This is bad.
No, it's not. I'm telling you, it's not. You don't like
It's not having morals.
Judgment Day will come. At the end of the day, it's mistake. It's not just mistake. It's on a spring.
So-
Electronic.
Just as a reminder, I think I put up into the My Notre Dame the end of the link to the end of the semester survey about whether you want to do a doubled high test score or test retake. Now, if you feel like you need to wait to see what your chapter 4 test is before you make that decision, I understand. But if you know right now, it's like I would have to get like a -5 to want to retake this thing, which I'm not going to do. I understand. Like, enter your stuff if you know what you are going to do. And I'll start entering that stuff kind of probably every day at some point. I'll check my survey results and see if people have posted what they want to do and then just enter it or whatever. Ideally, I'd like to have that stuff squared away by the start of next week, so that we can just, everybody knows where they're at before spring break, and then like nothing's going to change after that. Chapter 5 will be the last problem set. There's no quiz or test for Chapter 5, but we are going to do the problems. Because there's one specific type of problem in Chapter 5 that like we need to go over and like practice doing. Because I guarantee it'll be, you know, there'll be something like this on the IB exam because it's like the only thing from Chapter 5. Yeah, of course. But that's it for me. Does anybody have any final questions before I stop talking and let you guys do what you need to do?
Oh, wait, did you
Okay.
see this or no? 'Cause I was going to show you manually.
Yeah, let me show you.